Okay, everyone, we're going to take a look at a couple more problems from section 3.2, graphing linear models and unit analysis. So what I have here is I want us to be able to graph y is equal to 6. And usually when students look at problems like these, it's almost too simple looking for it to kind of make sense. Again, we're used to kind of looking at things in the form of y is equal to mx plus b. And now, instead of giving you that, I've essentially just given you y is equal to b. I removed the mx from you. And sometimes that doesn't sit well with people. But essentially what I want you to note is that this is actually a very direct and not too bad of an equation to graph. So if I were to create a table of values, I'm going to ask you, pick some values for x. And they do not have to match mine, and you'll understand why in a moment. But I'm going to go ahead and pick, let's say, -5. I'll do a -1. 0 is always a good choice. I'll do a 2 and a 3. And essentially what I want you to note is we have a set of instructions being presented to us in y is equal to 6. What these instructions say is the following. I don't care what values you select for x, the y values must be 6. So that means that when I come in here to fill in that right column underneath my y values, this has to be a 6, this has to be a 6, this has to be a 6, and so on. So my coordinate points are going to be -5, 6, -1, 6, 0, 6, 2, 6, and 3, 6. So go ahead and take a moment and create your graph. So as you can see, this generates a horizontal line. So whenever you are given something of the form y is equal to b, you are being asked to graph a horizontal line. So this would be no different, for example, if I changed this problem to y is equal to -2. Again, it's saying, I don't care what your x values are going to be, but every time you go to find a y value, it's always going to be -2. So essentially, this question is kind of like it's being a bit of a diva. It's saying, here are my demands, and they must be met. So again, now we're going to take a look at another option. What happens if you have just x equal to something? So with x, we have the situation where now I'm asking you to graph x is equal to -3. So again, if we were to create a table of values, here's my x, here's my y, even though I don't see a y. Again, remember, we do need to have a cause and effect. We need an input and an output. So maybe take a moment and think, how might this one be kind of similar to the problem that we just looked at? Keeping in mind that last time it was y equals something, and this time this one is x equals something. So hopefully what you're kind of noting is, well, this is saying something kind of along the same lines as previously. We're saying, I don't care what y is, but all of my x values must be -3. So in that case, I can kind of go crazy here and say, I'm going to pick, 206 for y, and, and then I'll bring it down to like a -2. Again, 0 is always a good option. Maybe a 3 and a 5. And I could also go kind of crazier and do 1,681,203. Sorry, I misread that. 1,681,203. But again, when it comes time to filling in my x values, -3, -3, -3, and so on. So obviously I can't fit all of these values in here, but go ahead and pause the video, graph with whatever values you've selected, and see what you get from this. So this time when we have x is equal to a constant number, I end up getting a vertical line. So as you can see, when we're presented these, it's completely understandable how it might be a little bit difficult to graph them at first because it feels like we don't have enough information. When in actuality, it's just being very, very strict, so kind of being a diva, having those demands, and then when we come through, we basically just have either a horizontal line if we are given y is equal to a constant number, or a vertical line when x is equal to a number. All right, that concludes lesson 3.2.